Okay, so when you took, okay, so on number 1, what would we use to solve for x? Number 1, Pythagorean theorem. Very good, PT. So we would use Pythagorean theorem, and we could totally solve for x. We could get an exact answer for x, right? A simplified radical. Number 2, what method would we employ? Yes, we would employ our 45, 45, 90 shortcut. 12, 12, 12 root 2. On number 3, we would do our good old 30, 60, 90 shortcut, since we learned about those, and we can use those from now on as long as the triangle has those angle measures. What about number 4? What are we going to do on number 4? Oh, the 20, 70, 90 rule, which doesn't exist at all? That one? Okay, so what's the point of this slide? The point of this slide is to show you that we know how to solve a lot of right triangles, but we don't know how to solve all of them. If you have a right triangle and you know one side and one angle, and it's not a special right triangle, as of right now, you do not know how to solve it. We have no tools. You could sit here and stare at this for as long as you want, and we have no tools to solve for x in this triangle. So that's why we need trigonometry, and that's what we're going to learn about today. So we're starting a new unit. It's going to be very short, and it's called trigonometry. Sounds really fun, huh? It's going to help us solve for missing sides and angles of triangles. So why do we have trigonometry? What is trigonometry, and who actually uses trigonometry in the real world? No, trig is this year, Johan. Trig is now. So, the first people that we know of that came up with trig were the Greek mathematicians, and they actually weren't just like drawing triangles in the sand like you picture. They weren't even actually studying math. They were studying astronomy. That's what they were interested in. They wanted to know how the planets worked, how the, sun and the moon, how far away they were, how things rotated, revolved, all of that. So they were studying astronomy. And obviously, with that kind of thing, you can't measure the distance. You can't measure the distance from the Earth to the sun. There are a lot of things that we can't measure ourselves. So we need to use triangles and angles to find those measurements. It's called indirectly measuring. So trig is going to help us find those really hard to find distances that we couldn't find any other way. Indirectly measuring. Other people that use trigonometry, composers. I know a lot of you are in band. Y'all are interested in music in general. And so if you've ever heard of a sine wave, it's represented, sound is represented with a sine wave, and that is trigonometry. Cartographers, map makers use it a lot because, once again, I mean, you're not going to measure the distance across Antarctica. You're going to need something else to help you find how far it is. So to measure distances that we can't measure directly. NASA uses trig a lot. We had a teacher who had a husband who worked for NASA and used trig all the time. So lots of places and careers that use trigonometry. There are more trig ratios out there, but the ones that we're going to study, and the 3 most common trig ratios, are sine, cosine, and tangent. So let's talk about how to say each one of those. So the first one is sine. Everyone say sine. Sine. It's not sin. That's one of my biggest pet peeves. So we're not going to call this sin. We're not committing a transgression. It's not a sin. It is sine. Even if you don't write the E, you still call it sine. The next one is called cosine. Once again, we don't call it cos. A lot of people call it cos when we shorten it, but it's cosine. And then the last one a lot of people don't have trouble with. That one is tangent, and you are more than welcome to call it tan. So what does trigonometry even mean? The first part of the word means triangle, and the second part of the word means measure. So it's really not as fancy as it sounds. We're finding measures of triangles. Sometimes it's going to be sides, and sometimes it's going to be angles. Oh, I'll have a trick about that later, I'll talk more about that later. So go to your graphing calculator, please. Get it out in front of you, and look for those 3 buttons. Sine, cosine, tan. You may have wondered what those buttons do. You may have played with those buttons and put numbers in there and get a really ugly decimal out, and you're like, I don't know what that means. Well, you're about to find out what that means. That's what the lesson is all about today. So, The most important thing, whether you're using your calculator or an online calculator or I don't even know if it's a function on your phone if you download an app for that, but the most important thing is that you need to be in degree mode. So if you have a calculator in front of you, you need to press mode, and you need to make sure that you're in degree mode. Radians are something that you're going to learn about in pre-cal. Radians are wonderful, and you will love them in pre-cal, but we're not going to touch on them in geometry. So you need to be in degree mode every time, all the time, or you will be 100% for sure to get your problem wrong. So make sure you're in degree mode. You put your cursor on where it says degree, and you press enter, and you make sure the degree is bold instead of the radian being bold. Okay, so when we are solving trig equations, there's going to be 3 scenarios, okay? Bear with me. I know you don't know what tangent is yet, and I promise to describe that. I promise that you will understand how this works. But first, we just want to go over these simple steps. Your variable could be in 3 different spots. Take a look at scenario 1. Where is the variable? The variable is in the numerator. Scenario 2, where is the variable? Oh, it's in the denominator. And scenario 3, where is the variable? It is in the trig function. Okay? So these are the only 3 situations that you can come up with. The trig function, yeah. So it can be in the numerator, in the denominator, in the trig function. Let's find out how we would solve each one, even though we still don't really understand what the calculator is doing when we press this button. Okay? Number 1, I want you to think of this as a fraction equals a fraction. How do we solve something when a fraction equals a fraction? Yay! Thank you, Johan. You win. You cross multiply. 19 times tan 23 equals x times 1, right? So we're going to end up multiplying. When x is in the numerator, we're going to end up multiplying that number in the denominator times our trig function. Well, what happens here when we put this over 1? We're going to do 19 times 1 divided by tan 23. We're going to cross multiply and divide. So that one is going to end up 19 divided by tan 23 equals x. So in this one, we are going to divide. In this one, we are multiplying. So the way that I remember this is with an alliteration. That's when 2 things start with the same sound. Denominator divide. So when x is in the denominator, you're going to divide. As long as you put the number first. You have to put the integer first and then the trig function second, okay? So denominator divide and then numerator multiply. It's almost an alliteration. M and N are close in the alphabet, but not quite. So just remember denominator divide. Abby, you can make a song if you want. Okay, now what are we going to do when x is trapped in the trig function? Normally when you're solving for a variable, you do the opposite of what's being done to it. What's the opposite of tangent? We need to undo tangent. Nope, it's not sine. Nope, not divide by tan, because it's trapped inside it. We need to undo tangent. It's not being multiplied, it's inside. Nope, it's not cosine. Look closer at your calculator. Rip it open. Okay, sure. Yay! Rishi wins! Rishi wins. Do you see above the tan button? Do you see right above the tan button, it says tan to the negative 1. Does anyone know what that means? It starts with an I. Inverse. It's the inverse tan function. Inverse trig. No, I didn't freeze. I was waiting for you to answer. So, tan to the negative 1 is inverse tan. It's the opposite of doing tan. It's how you undo tan. It's inverse tan. So, what do we do each time? We now know what to do every time. When it's in the numerator, we multiply. When it's in the denominator, we divide. And when it's stuck in the trig function, we do the inverse of the trig function. Okay, so let's practice some of these. Go ahead and solve all of those, A, B, and C. Go. Okay, so some of you are saying you don't know what to do. So we talked about 3 scenarios. When x is in the numerator, how do you solve for it? You cross multiply. But you're going to end up multiplying the number times the tan function. When x is in the denominator, you're going to divide, and when x is trapped in the trig function, you're going to do inverse. So on this one right here, where is x? X is in the numerator. On all of these, x is in the numerator. When x is in the numerator, you multiply. So like on this one, you're going to do 19 times tan 23. On this one, you're going to do 35 times tan 54. On this one, you're going to do 27 times tan 62. Make sure you're in degree mode. Very good. Okay. Johan got 8.07, I guess. Are y'all getting the same thing as Johan? Tahir got, oh goodness. 8, you got the same thing. Let's see. 35 times tan 54. This one is 48.17. 27 times tan 62. This one is 50.78. All right, looks good to me. So this would have been a 7 if we're going to round to the nearest hundredth on all of them. Okay? 8.07, 48.17, and 50.78. What questions do we have? You don't need to close the parentheses because honestly, if you're going to put the number first, which you should, 19 first, times tan 23, you're not putting anything after this. As long as you're not putting anything after the 23, you don't have to close the parentheses. Yeah, let's just not ever put tan, never put the trig function first, ever. Because then you don't have to remember to close the parentheses. If you do want to put it first, just close the parentheses. Adriel, make sure you're in degree mode. Go to your mode. When x is in the denominator of the fraction, we are going to divide. Denominator, divide. So everyone practice doing that. Okay, try these, Adriel. Juan, tell me what you get for A. We're going to round to 2 decimal places. Victor, your B, and V, there we go, your C. Okay, very nice. Everyone was doing it very nicely. You do have to put the number first on this time. The other one, when you multiply, it doesn't matter which one you put first, but when you divide, it absolutely matters. So you need to put the integer or whatever the number is in the fraction first and the trig function second. If you just get used to doing that every time, you'll be good. So this one was 44.76. This one was 25.43. And this one was 14.36. We still have no idea why we're doing this, but we're practicing, aren't we? Okay. Next one, last situation, scenario 3. When x is in the angle, we have to get it out. When x is the angle, we have to get it out. So we need to do the inverse of tan. We need to do the opposite of tan. Yes, you'll have homework tonight, and you'll do it more when you get home. So we're going to do inverse tan. In your calculator, you need to press second tan to get that inverse. Oh, good question, Rishi. No, you press second tan, and then you put the fraction in. So your calculator, it should look like this, and then you do this. You don't have to close the parenthesis because you're not putting anything after it. Anna, you have A. Rishi, you have B. And Edriel, you have... So if we are going to round to a whole number, then A is a 26-degree angle. B is a 21-degree angle. Did you try again on that last one, Edriel? Oh, every time you change it, it goes back to radian? What do you mean every time you change it? Don't ever clear it. Don't clear your calculator because it'll reset. This one's a 65-degree angle. Press enter on it. Okay, so now we're going to talk about the pieces of these functions. We've been solving for x, but we don't even know the parts of these functions. Okay, so when we're writing a trig equation, we always write the trig function first, so like sine, cosine, or tan. The angle always goes in parentheses. That's where the angle goes. Then you put an equal sign, and then you use your triangle sides, and we'll learn more about that later. But if you want to write this down in your notes, I'll give you a minute. You do the trig function, then the angle goes in parentheses, and then the triangle sides always go in the numerator and denominator of the fraction. Some people were writing that down. Okay, now we're going to identify different parts of the triangle. We are jumping all over the place. I know. This is just how day 1 of trig is. Day 2 tomorrow will make a lot of sense. Okay, so we have this cute little guy here that looks like a Boy Scout. If he's standing at angle C, so that's going to be our perspective. Our perspective is angle C. Compared to our little Boy Scout guy at angle C, which side is opposite? Which side is opposite our little boy? Good. AB is opposite. Which side is adjacent? Wait, there's 2 sides that are adjacent. So let's scratch that. Which side of the triangle is our hypotenuse? AC is the hypotenuse. And then BC, we're going to call the adjacent leg. Okay? It's important that we're able to label these because this is the foundation of trig. We need to know which side is opposite, which side is adjacent. Adjacent means next to. And then the hypotenuse is never going to change. That's constant. So the opposite and the adjacent will change depending on what angle you're looking at, but the hypotenuse will never ever change. Okay? It does say leg. You're right. All right, so now we have little Mr. Egg. I don't know. I didn't choose these graphics. So compared to Mr. Egg, which one is opposite? Humpty Dumpty, yeah. Which one's opposite? Okay. BC. Which one's adjacent? Oh, come on, adjacent. AB. And then, of course, like I said, the hypotenuse never changes. The hypotenuse is always across from the right angle. Okay. Woo! So, now we're going to go back to that warm-up. Okay. This is where something might click in a minute. I want everyone, look, do you notice that what was the same between all of these angles? First of all, for all these triangles, first of all, they were all right triangles. Second of all, the sides changed, but the angle remained the same in all the triangles, right? These should be different sizes. I mean, that middle one was 80. I didn't change the size because I didn't have enough room on the slide, but those are different size triangles, but they all have the same angles. So, when we did the opposite of 25 divided by the adjacent, when we did this divided by this, we got 0.466 all 3 times, right? 0.466 all 3 times. I want you to go to your calculator, and I want you to type in tan 25. That's the angle. I want you to type in tan 25. Whoa! Is it 0.466 if you round it? I know it's not going to be exact because the decimal goes on forever. 0.466. So the tan of 25 is 0.466. The tangent of that angle is the opposite divided by the adjacent. 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 Trig Tangent is just a ratio. Do you know what your calculator is doing? It's just dividing a side by a side. In tangent's case, it's dividing the opposite by the adjacent. It doesn't matter what triangle you have. The sides could be all different lengths. But if that angle is 25, then no matter what the lengths are, the ratio is going to remain the same. You know how 1/2 is the same ratio as 3/6? Because they both reduce to 1/2. In all of these triangles, the ratio of the opposite over the adjacent is 0.466. It reduces to that every time because of the angle. That's okay if you don't get it. I just wanted you to know what your calculator's doing when you type tan. All it's doing is it's dividing a side divided by a side. You just did tan by yourself because you divided 5 by 10.72. You divided 80 by 171.56. Trig is simply a ratio. It's a division. And that's what your calculator's doing. If you don't understand it, it's fine because your calculator still gets it. So you don't need to worry about that. All right. So write this down in your notes. This is the most important thing of today. We're going to focus for the rest of today only on tan and tan alone. The tangent ratio is the opposite over the adjacent. The opposite over the adjacent. Do y'all know what they did back in the day when they didn't have calculators to do trig? Do you know what they did? Does anyone know? They cried. Math. They did math. They had tables. You can't do trig by hand. This is one thing that you just can't do by hand. Kind of like you can't take a square root by hand, like turn it into a decimal. You can't really take a square root by hand. You can't do trig by hand. So they had trig tables. They had to match up, ooh, here's the side and here's the side, and they'd meet in the middle and they'd be like, ooh, there's the decimal right there. They had to use a table and meet and find the different ratios. So they used trig tables before they had calculators. I even was taught how to use one in high school, which is crazy. I know. That makes me feel old. All right, so let's find the tangent ratios in a triangle. We're actually not going to be solving for anything. We're just going to find the ratio for right now. What you need to do is the first thing I always do is I circle my angle. Circle your angle. We know that the tangent ratio is opposite over adjacent. We don't use the hypotenuse for tangent at all. So for today, I would just cross off the hypotenuse. We're not going to use it at all. Opposite over adjacent. So what is opposite angle A? Well, it's 3. What's adjacent to angle A? Well, it's 4. So the tangent of A is 3/4. We're not solving for A yet. That'll be later. The tangent of A is 3/4. What would the tangent of B be? Well, if you were at B, what would be opposite you? Opposite over adjacent. So notice that the tangent of the two different acute angles, they're reciprocals, right? No, you don't put it in the calculator, not for these. So the tangent of A is 3/4, the tangent of B is 4/3. Let's try another one. The tangent of S. I'm going to go quickly because I know some of you have to leave. Opposite over adjacent. So what's opposite of S? 30. What's adjacent to S? 16. Do we ever in our entire lives leave our answer unsimplified? Nope, we never do. And so we put it into our calculator. If we need to do math enter, we do. If we want to reduce it by hand, that's great too. And then we can find the tangent of T, or we can just remember that it's going to be the reciprocal of the tangent of S. And so you can go straight to this if you want. Opposite over adjacent. Can't say that enough. Opposite over adjacent. Okay, here we go. We are actually going to solve for a missing side now. All that background stuff was getting us ready for this slide right here. Let's find a missing side of a triangle. Here we go. So, how do we do this? First, we need to write the word tan. Everyone write the word tan. Then, the only thing ever allowed in the parentheses is the angle. You put the angle in the tan function every time, no matter what. That's the only thing allowed, is the angle. I'll go ahead and put a degree just so we remember it's an angle. Then you put an equal sign, because these are always going to be equations. And then you put opposite over adjacent. Opposite over adjacent. X is opposite because it's far away. It's across the triangle from the 43. Now we did all that practice to get us ready for this. This is what we were working on. So where is x? X is in the numerator. Remember it could be in the numerator, the denominator, or it could be trapped in the trig function. X is in the numerator, so we're going to do 12 times tan 43. X is in the numerator, so we multiply. If it were in the denominator, we would have divided. So, Adriel, what'd you get? 11.2? 12 times tan 43. Very good. Round to the nearest hundredth. So it'd be 11.19. You got this, guys. Let's do another one. Okay, circle the angle. There we go. Tan of 23 equals, make sure you put the opposite over the adjacent. You grab the opposite first. Opposite over adjacent. Where's the variable? The variable's in the denominator. Denominator divide. You have to put the 18 first. You cannot put tan first. You have to put the 18 first. 18 divided by tan 23. And you get 42.41. Okay, good. Okay, here's our last situation that could happen. We could be missing the angle. Trig can even find angles for you, not just sides when you're missing angles. We can do it. Trig can do it. So you write tan. You always put the angle in the tan function, even if the angle happens to be the variable. So tan of x equals, now we're going to do opposite over adjacent. Opposite over adjacent. X is trapped in the tangent function, so we are going to do inverse tan. So we press second tan, and then we do 17 divided by 26. So second tan, opposite divided by adjacent. Let's round to the nearest degree. That means whole number. So what degree is that angle? Good, Rishi. It's a 33-degree angle. 33-degree angle. Cool. We are going to stop there. I'm going to let you go. I think there's a couple more examples that I'm going to work just for the recorded lesson, but if you need to get going and work on your homework tonight, okay? This one was probably trying to trick us by drawing the altitude of the triangle, but it's not going to make it any different for us. We're going to circle the angle as always. We're going to write tan. We always put the angle in the tan function. And then we want to do opposite over adjacent. We are working with this triangle right here. We're not really worried about that part right there. X is in the denominator. Denominator divide. 6 divided by tan 54. You always look at where the variable is. Denominator divide. 6 divided by tan 54. And that's a pretty short side, huh? 4.36 if we round to the nearest hundredth like it tells us to do. Okay. Oh, that's it actually. We'll do some more complicated ones tomorrow along with going over sine and cosine tomorrow. Bye!